Recording in progress.
Right. Good morning to you all. So, have you completed the quiz? Quiz was available 10 to 11 today. Have you completed?
Yes, miss.
Right. Okay. So, I think this is the last lecture, last session we can have. So, today I'm going to complete this geometrical optics part. Actually, when you take optics, there are three main branches like geometrical optics, then wave optics, and then actually the quantum part. So in your syllabus, we are focusing only on geometrical optics. So what is this geometrical optics means? Any idea? So if you take light, right? So we already discussed this EM waves and the visible light and all. So you already know you can treat light as a wave, right? But in here, under the geometrical optics, we assume or we approximate the light wave as straight line, or we call it as ray, right? So the studying properties of light, treating it as a straight line or ray, we call it as geometrical optics, right? So when a ray of light hits the boundary between two transparent materials like this, right? So here you can see some kind of liquid here. And then here you have air. And this is the light ray, light beam. So once it hit this boundary, right? Boundary between two materials, two transparent materials. So you can see this ray is divided into two. We call it as reflected ray and refracted ray. So the portion of this light refracted and then the rest of the light reflected. So when you're studying this geometrical optics, this what you call as ray diagram plays important role. So this is the ray diagram equivalent to this phenomenon. So here you can see it's water. Here it is the air. So we have light ray. Again, this is not the real case, right? Light you can treat as a wave. So that's why here you can see wave front as well. So we approximate that light wave as a straight line, like this. So we call it as incident ray. Incident ray, right? And part of that reflected. Reflected and rest of the light refracted, right? So these angle, theta 1, theta 2, theta 1 dash, we have separate specific names for these rays and the angle. So this one we call as incident ray. This one we call as refracted ray. So we'll discuss the angles later. So here you notice that there's a two way of propagating after hitting this boundary. There's two ways of propagating the light. One is reflection, other one is refraction. So the reflection is the return of light from a surface. So light will come back. First light will meet some boundary. After that, it come back to the same medium. We call it as reflection. So here you can see. Here you have boundary. Most of the time it can be a mirror. So light hits this boundary and go back to the same medium. So this is what we call as reflection. And actually there's a law for the reflection equating these angles. So theta 1 here, we call it as incident angle. And theta 1 dash, here is the reflected angle. So the law is this theta 1 is equal to theta 1 dash. That is the law of reflection. Light will reflect with the angle same to the incident angle. Right? So then, what is the other way of propagating light when it meets some bound? That is refraction. Right? So refraction is bending of light as it passes from one medium to another. So if you take this one, so what are the two mediums here? I think this is very practical example. Once you see in home or in the laboratory something in water, most of the time straw in clear water or other kind of uncolored liquid. So you can notice it has like broken, like this one is broken at the boundary, right? I think all of you have seen this. Anyone? Not experience this one. All of you have seen this, right? Okay, I think, yes, this should be a day-to-day life experience. So then what are the two mediums in here? Can somebody tell me what are the two mediums here? Because refraction occurs between two mediums, not as reflection. Tell me what are the two mediums here or here. Here you can see kind of a ruler in water basin. Here pencil or straw in water glass. So what are the two mediums here and here? Yes, I got to answer. Yes, right. Air and water. This is water, this is air. So at the boundary, so here also boundary is this one. Here you have air, here you have water. So at the boundary, light is bending. Light is bending. So this phenomenon we call as refraction. Actually, what is the reason behind this? What is the actual reason? Waves change speed when they travel from one medium to another. This should be one medium to another. So due to that, due to the change of speed, this phenomenon occur. Like right. So this is the ray diagram relevant to refraction. So this one, the previous one is the ray diagram relevant to reflection. Actually, it has part of refraction as well. So this is the ray diagram for refraction, right? So here definitely you should have two mediums, right? So this is the incident ray, this is refracted ray, and this one, this line which is perpendicular to the boundary, we call it as normal, which is a line drawn at right angle to the boundary, right? And this angle between normal and incident ray, we call it as incident angle. And the angle between normal and refracted ray, we call it as refracted angle, right? Is this diagram clear? And one thing you need to notice is the bend of the refracted ray. So if this light travels from less dense to high dense medium, then this refracted ray will we'll try to make it towards to the normal. If it is from high dense to low dense medium, then refracted ray will away from the normal. So it will make angle which is greater than I. So let me explain you. So if the light ray travels let's say like here, air to water. Can you see what I'm writing?
Yes, madam.
Right. So this is the normal. So now let's say this is the incident light. So this is the eye. So then refracted ray will try to make it towards to the normal because this is high dense. So definitely it will take some angle like this. So this is the refracted angle. So which is less than I when you compare it with the norm. And if it is the other way, let's say water to air. You have incident angle. So now refracted ray, try to make it away from the normal because now this is the high dense medium. So it will make angle than this, somewhere like this. This is the R. This one. This is the R. angle in between normal and the right. So what you need to learn here is refraction of light involved with two medium all the time. Reflection is with one medium. Actually, it's like light is coming back to the same medium. And in the refraction, if the light travels from less dense to high dense, so it will make its angle toward the normal. If it is high dense to less dense, it will make the angle away from the normal, right? So as we have law for reflection, we have laws for the refraction as well. First law is the incident ray, the normal, and the refracted ray all lie in same plane. So here these three, normal, incident ray, refracted ray, all these three are in one plane, same plane. Then the second law is the ratio of the sine of the angle of incident to the sine of the angle of refraction is equal to the ratio of the refractive index. Now, if you take any medium, that medium have refractive index, right? It's a constant for a given medium. So that is of first medium to the that is of second medium, right? So this law we can present this way. The ratio of the sine of the angle of incident, that means sine value of this incident angle, sine r, to the sine value of refraction. So to the sine value of refraction is sine value of this r. So sine r, this is equal to refractive index of the first medium, right? Here it is first medium you can take as air, second medium take as water. So this should be first medium, the second medium, right? It is come in other way. Sin I divided by sin r equal sin I is the incident angle. So the refractive index of the other medium, that is water. Then R is refracted angle, refraction angle. So their medium n of the index of this medium is air, right? Actually, the easiest way of keep in mind this is starting from the first medium, right? So now light goes from air to water. So start here. Reflective index of air, and air into sine value of that incident angle sine I or sine theta 1 equal, go to the second medium, their refractive index number, that means in water, into the sine value of refracted angle sine r, sine theta 2. This is refractive index of media 1. This is refractive index of media 2. This is incident angle sine value. This is refracted angle sine value. So we call this one as Snell's law. Snell's law. So in the reflection, the law is this, the angle of incident is equal angle of reflection. In refraction, the law we call it as Snell's law. So it means refractive index of media 1 into sine value of incident angle equal refractive index of media 2 into sine value of refracted angle. So we call this one as Snell's law. Right. You have two examples. So please try this, taking few minutes. Are there any questions regarding the laws of refraction and laws of reflection? Is it clear? Seems no questions. Right. Try these two examples and send me your answers as well. I'll give you a few minutes. Any answers? Question was not shared. Wait. Any answers? Hello? So if you are not actively participate, I have to stop the session. No one is answering the questions.
තාම හදනවා මට.
හරි. Yes, there's a one answer from Chamila. Oh, yes, Chamila Chamodani. Yes, your answer is correct. 23 degrees for the example 1. So what about the others? Did you got the same? 23 degrees? So what this says, you have a beam of flashlight traveling in air incident on the surface of a thin glass. So first thing you need to identify the mediums and boundary and the direction of light travel. So it is clear the two mediums are air to the glass, right? So we can mark the normal. So beam of flashlight traveling in air incident. So which means light incident this way. Now this is less dense when you compare with the glass. So definitely this will take direction of towards to the normal. Wait, erase. This will towards to the glass. So now applying Snell's law, and it is given incident angle, it is 38 degrees. Incident index of refraction of the glass, it is 1.56. So starting from the first medium, refractive index of air, in air into sine I equal refractive index of glass is given 1.56 into sine R. So in air, refractive index of air is 1. So you need sine 38 here. 1.56 sine R. So you can find sine 38 value and find the value for sine R. So it will be sine 38 divided by 1.56, nearly 0.3947. So the R equal sine inverse 0.7. Nearly it is 23.25 degrees. Right. So now try example 2. This one. Try this one.
Oh, ඒක display po. Hai. Nah. Ba. Lectures. Lectures. Well, here.
Any answers?
ආවට පස්සේ කැමති නේ
දෙන්න සල්ලි දෙන්න. දෙන්න 1000ක් දෙන්න. හරි ඔක ඕඩර් කරන්න.
ඕඩර් කරන්න අනේ 10.
හරි මං දෙන්න.
බෑ එහෙනම්
1000යිනේ.
ඔව්
1000 දෙන්න.
10 දීපන්
හරි දෙන්න. ඔය ඕඩර් කරන්න.
ඉස්සෙල්ලා දීලා ඉන්න
හරි දෙන්න.
යකෝ සල්ලි ගෙවලා ගන්නවා
සල්ලි ගන්න මම බැංකින් ගෙවන්න.
ඒක තමයි 10 දීපන්
ඔයාට මං ගෙදරට ආව සල්ලි දෙන්න.
එහෙනම් සල්ලි දීලා ඉන්න ඉස්සෙල්ලා
ඊට ගෙදරට ආයතන
ගෙදරට ආයතන සල්ලි ගන්න
බෑවා දෙන්නේ. ආ ඕඩර් එක දාන්න මම ඔයාලට මේ ගෙදරට ආවම දෙන්න. අනේ ඕඩර් කරන්න ඒක. ඔච්චර අඩුවට
නිකන් මේවා මට මේ මෙම්බර්ෂිප් එක හම්බුනේ එකට සේල් දීලා
මොකක් හම්බෙච්ච එකද?
මම දඩස් එකේ හිතා පාරේ බෝපි දී
අනේ දැන් ඕඩර් එක දාන්නකෝ.
ඒක අද
සිද්ධි එකක් ඕන.
ඒක පාටියෙන් බෑනේ
ඇයි?
මොන්නේ නෑ
කල්විට දෙන්න.
අර කොයි පේන්නේ නම් කියන්නේ
දෙකක් දාන්න.
දෙකක් දාන්නේ තවුස සල්ලි දීලා ඉතින්
අයව සල්ලි වෙන්නන්න මොන්න.
වෙන්න රවයි චලි
හරි මං ගාව සල්ලි දෙනවා 1000.
හොඳයි කන්නම් වෙන්නේ හොඳයි මේක නෙමෙයි
හොඳ එකක් කියන්නේ 1000ට තියෙන හොඳ එක දාන්න. මේ පාටත් එක බලන්න.
ගාලා මේක ලස්සන ඒක තීම් පෑඩ් එකේ
ඔච්චර සල්ලි නෑ නේද?
දෙනෝ එක
ඔච්චර සල්ලි නෑ. අනික ඕඩර් එක දාන්නකෝ.
ඉස්සෙල්ලා 10 දීලා ඉතින් 10
සල්ලි දෙන්න.
ඈ
අකාලතර පස්සේ මට සල්ලි නෑ.
අයනවා බං
හරි හරි මේකේ ඕඩර් එක දාන්න.
ඉස්සෙල්ලා සල්ලි දීපන්
හරි සල්ලි දෙන්න.
සල්ලි දුන්නාට පස්සේ
ඕඩර් එක දාන්නකෝ.
ඕඩර් එක දාලා සල්ලි ගන්න සල්ලි කියලා ඔතන
දාන්නකෝ. ඔයා මට ඊට පස්සේ සල්ලි දෙන්න හොගාවල තුනම.
කියනවා බං
ඒ ඔයා දාන්න කෙනවනේ.
තවුස සල්ලි ගෙවන්නේ නැහැ
දෙන්න.
තවුසේ ෂුවර් නෑ
ඈ?
තවුසේ ෂුවර් නෑ
මට තවුසස් වෙන්නේ අකාලතර පස්සේ මට සල්ලි
ඉතින්
දෙන්න.
මේක ඕඩර් එක දානවා මෙතන දැන් සල්ලි දීපන් ඕඩර් එක දානවා
ඉතින් ආනකෝ.
ඒකයි නැති වෙන්නේ නෑ බං
හරි දාන්නකෝ.
ඊයේ
එයා දාන්න සල්ලි දෙන්න. පාවිච්චි කරපුවද?
නෑ බං ගෙවි
දෙකම ඒගාන්ට තියෙන්නේ. යා මේ එකක් තියෙන්නේ නැත්නම් අර ප්ලාස්ටික් එකද?
ප්ලාස්ටික්
හරිද?
ලයිට් එකක් තියෙනවනේ
රවුම් එකද? අර ගෙදර තියෙන ජාති රවුම් ගන්න නෑනේ. ඕකද තියෙන්නේ? මේ රබර් ගෑල්ල තියෙනවනේ.
මේක ලයිට් එකක් තියෙනවා මේකෙන් වත්
ඉතින්
ලයිට් එකක් තියෙනවා
පාවිච්චි කරනකොට අර වගේ රවුම් එක වගේ. එක 1000ක් නෑනේ කීයද 800 ගාන 900 ගාන දෙකනේ.
ඒකද මගේකද
නෑ නෑ දාන්නේ
998යි
අද 800 ගාන
ඒක හෙල්ලා බං එක ගන්න මම ඊට වඩා වැඩි ගන්න ගන්නවා
998 දාන්නකො ඉතින් හොඳ එකක් බලලා.
මේ තියෙන වෙන එක. ඒක.
අර දානවලට මේකට තියෙන එකක් දාන්නද.
මේ 98 එක වෙන එක.
ෂුවර්නේ 1000 කියලා 10ට වැඩි වෙන්නේ නැහනේ.
වැඩි වෙනවා.
කීයද?
1088 82.
එච්චර 82යි. හරිද?
82යි නෙවෙයි හරියට ගත්තොත් ඩෙලිවරි මේකත් එක්ක 1200
නෑ 1200 ගන්න මම දෙන්න ඕනද?
ආව 1238යි ඊට පස්සේ මට හම්බ වෙන මේ වවුචර්ස් පාවිච්චි කරන්න ඊට පස්සේ මට වවුචර්ස් නැති වෙනවා. එතකොට අඩු වෙනවා.
කීයද තවද දැන් ඔක්කොම ගන්න?
1200 ඒ 92 මේ 82යි. දෙකේ එපා මට 85.
යව දෙකේ 85. ඇත්ත?
හරි මම වවුචරේ දාන්න. දැන් දීපන් 1232ක්
අනේ නෑ. යා දාන්න.
වවුචරේ දාම මට තව එකක් ගන්න තියෙන chance එක නැති වෙනවා. වවුචරේ පාවිච්චි කරනවා ඒක නිසා.
අවුචස් කීයක් තියනද?
No answers yet. Okay, then let's see.
යෝලියන්නේ නැද්ද? අප දාන්න මම සල්ලි දෙන්න.
හො දැන් දීපන් 1200.
100ක් මාරු අන්තරම් දෙන්න.
I have to open the whiteboard. I think question you can remember. Right.
ඔබ දාන්න. හරි සල්ලි දෙන්න.
හො දැන් දීපන්.
හරි දෙන්න.
So now you have kind of,
දාන්න.
according to the question, you have a glass block,
ඈ?
right?
බෙදාලා දෙන්න. කන්නේ නැද්ද? අයියේ.
And it is in,
මේ
yes, that's the
ග්ලාස් බෙදලා තියෙනවා.
question is not clear. Can you see the question and the whiteboard together now?
නෑ.
ගයි.
ඉතරව මම මාසෙ. පාට බලන්න.
මේකත් ඒ වගේ තමයි. මේක
Hello.
රවුන්ඩ් එකට තව කෝරකුත් තියෙනවා. ඒක වෙන්නේ.
ඉතින් කූර හොඳයි. කූර හිටිනවා කන්න. අර තනියක තියෙන ඒ වගේ ගන්නකො.
Can you see the question and the whiteboard together?
අරක හරියන්නේ එක බර වෙච්ච ගමන් වැටෙන්නේ නැහැ මට බය.
Hello?
Yes, ma'am.
Right. So question itself says you have uniform rectangular block of glass, right? So refractive index given 1.56, surrounded by some fluid with refractive index of refraction is 1.63. So there what you can take, so you have kind of glass block,
නැහැ.
දැන් දාලා
so it has
අන්නේ කොනේ
surrounding had kind of another medium, right? So then it says this is n equal 1.56 and this is n equal 1.63. Beam of light incident strike at point of glass block at the angle 32 to the normal. I'll take another color. Right. So now let's take, this is the
ඒක මගේ.
angle of incident. It is 32.
අනේ මේ නිකන් ඒක අම්මා
And
කියන්නේ.
it asks at what angle does the light beam leave the slab? So here now first incident is this one, right? So now you have n equal 1.63 medium to n equal 1.56 medium. So what is the denser medium?
අයි. Right?
So you can decide that using the index of refraction. So index of refraction high means it is denser. So once you compare this glass and the liquid, so we can say light travel from high dense to low dense. So definitely this will away from the normal. So it's really hard to draw this online. Yes. Pen. Then here again you have incident now. So this will, let's take R1 refracted. So using the trigonometric, this also R1. Then what happened? This is 1.56 to 1.63. What happened? Is it low dense to high dense or other way? It is low dense to high dense. So this is towards the normal. Oh, let's say this one. So question asks, at what angle does the light beam leave the slab? Actually, it asks this angle. Let's take it as alpha. So how do you find it? So you can use Snell's law. First, you can apply Snell's law this point. Let's take point A and to the point B. So applying Snell's law at point A. So starting here, you can see index of refraction, it is 1.63 into sine value of incident sine 32 equal refractive index here 1.56 into sine value of the angle sine R1. So by simplifying, you can take sine R1 as 1.63 into sine 32 divided by 1.56, which is once you calculate, it will nearly 0.5537, right? So R1 you can take as sine inverse 37, which is nearly 33.62. So this angle now 33 nearly. So which means at point B, the incident angle will nearly be 33 degrees. So apply Snell's law at point B. Start from here. So n is 1.56 into sine R1 equal 1.63 n of second medium into sine alpha 1.56. Actually sine R from here directly we can apply 0.5537 1.63 into sine alpha. So sine alpha you can calculate using these values, right? So which is 1.56 56 into 537 divided by 1.63, which is 0.52. So therefore, alpha equal sine inverse 0.52, nearly 32. So this is the leaving angle. So this is a glass block, but you will experience when you are when the light incident with 32 angle, it will leave the glass block with nearly the 32 angle with same angle. Is it clear? Is it clear? Hello?
Yes, ma'am.
Right. Okay, then. Right. Let's move to the next. Right. So when you discuss this refraction, actually there's a angle we call as critical angle. So what is this? The angle of refraction increases as the angle of incident increases. So again, this happens when light travels from denser medium to low dense or rarer medium. Why? Now here, this is the incident angle, right? So this one, when the refraction occurs, it tried to move away from the normal. It's like this. So let's say this is the first incident angle, right? This is water. This is air. So this will move away. Then I am increasing this angle, right? So now I will increase angle like this. So once you increase this angle, this one also increase. So it will again goes like this. Now angle is this. Then I will increase more. Like this. So it will go like this. And once I increase and increase, there will be a incident angle which this refracted ray goes along this line, along the surface, right? So if I increase more, right? Increase more, there will be an angle which is light goes along the surface. So then this angle we call as critical angle. So at some point, the angle of incident reaches a point where the angle of refraction is equal to 90. This is 90 now. The critical angle of a medium is the angle of incident which produces angle of refraction of 90 degrees. So same phenomenon. right? So what we are doing here is we will increase this incident angle till the refracted ray goes along the surface. So the incident angle which make this refracted angle goes along the surface, we call it as critical angle. Is it clear? So this happens when light travels from high dense to low dense. If not, this refracted ray try to bend towards the normal, no? So then you cannot obtain kind of this increasing refracted angle. Right? Any questions? Any questions? No? Okay, then let's move to the next. So you can apply Snell's law for this position as well. So start with this medium, n of the medium 1, n1, sine value of the incident angle. Now the incident angle is this C. So sine C equal n2, n value or the index of refraction of medium 2 into sine R. Actually R is 90 now, refracted angle. So applying 90 value for the R, we know sine 90 is 1. So we have therefore sine C equal n2 divided by n1, which is critical angle you can obtain from sine inverse n2 divided by n1. So again, I like to advise you, don't just by heart. Critical angle is equal sine inverse n of the medium 2 divided by n of the medium 1. Just apply Snell's law for the situation. That is the easiest way. Right? Anything to discuss? Okay, then try this example. Try this example. Refractive index of glass is given. It asks the critical angle of glass. Please mark the attendance. Please make sure to mark attendance. What is the answer? So here you need to find critical angle of glass. You are given refractive index for glass. So there's a message that they couldn't mark the attendance. Why? We can't reproduce it. It's only one time. Right, let's do the question. So you need to find the critical angle. So if you need to find the critical angle, as I mentioned before, the light should travel from high dense to low dense medium. And you need to find critical angle of glass. Therefore, light ray should start from the glass. So, and the easiest or well-known refractive index medium is air. So we can consider therefore light travel from glass to air. Right? So let's take, this is glass, this is air. So we have the normal. Since this is critical angle, this is C, so light will go here. So this is 9. So apply Snell's law here. So refractive index of glass, Ng into sine C, sine value of the incident value, then N air, and this is sine 90. Ng is 1.5, sine C and A is 1, sine 90 also 1. So Sin C equal 1 over 1.5, which is 0.6667. So C, critical angle is sine inverse point. Once you calculate, it is nearly 41.81. Right? So if you put, if the light incident glass with the angle nearly 42 degrees, so the refracted light will go along the surface. Yes, Chamila, your answer is correct. 41. That's right. Right. So what happens if we increase the incident angle more and more? So initially we learn it will refract, then it will refract along the surface at the critical angle. And if I increase this incident angle more, like this, right? So here, this is the source, right? So light emits, which is along the normal line, it will goes along the normal line. Then once I increase the incident angle little bit, it will reflect. Once I increase more, it will reflect more. Incident angle increases, reflected angle also increase. There are some point when incident angle increases and it will go along the surface. So we call this angle as critical angle or critical case. So if I increase it more, right, what will happen? There will be this refracted ray which is convert to reflection. So now this light go to the same medium again. And in these cases also you can see small part of the incident light reflected, right? Partially reflect. So as the angle of incident increase, the angle of refraction increases. For angles of incidence larger than critical angle, when this incident angle is larger than critical angle, there is no refracted ray and all the light is reflected, right? Like this. This effect is called total internal reflection. So this one we call as total internal reflection, like this. So sometimes you may see in like fish tanks, like, so you have light source inside the water. So there are light rays which is refracted and going along like this. Then sometimes it is totally reflection. We call it as total internal reflection. Right? Right. Now let's consider, we'll give our attention to this mirrors and lenses. Now you know the phenomenon reflection and refraction. Then critical case. Then total internal reflection. So then these mirrors and lenses are one of the objects that you deal with in your day-to-day life. So how do we see images in mirrors? So if you keep something in front of the mirror, you can see. Actually, every day before coming to the campus, you will get ready with the support of mirror. So how you see those things? your hair, your clothes. How you see? So, what phenomenon supports reflection or refraction? It is from the reflection. So, here you can see if you have a candle in front of the mirror, you can see the candle from mirror, not from the other side, from the mirror. Why? Light from the object reflects off the mirror and converges to form an image. Right? So that is how you can see from the mirrors. So mirrors support for the reflection. Then what about lenses? So sometimes you may use spectacles. Or if you are working with the bio-related stuff, you will use lens to see these tiny parts. So what happened? These lenses are made of transparent materials like glass or plastic. How it works? Light from the object refracts, which means bends, as they pass through this lens, and you will receive it to your eyes and see the object in large scale. Right? You can see light from here will goes like this. So what you receive here is enlarged thing than this. So there are two types of lenses: convex or converging lens, concave or diverge lens. So here light rays refracted in a way to bring them to a point. In convex lenses, light will converge to some point. We call that point as focal point, and this as focal length. And concave or diverge lens, there these lights refract in a way to spread them out. After going through the lens, light is spread out. But if you take this dash line, which is like imaginary lines drawn from the refracted ray, again you can see it is spread out from kind of a point. We call that point as a focal point. Right? So in convex lens, you have focal point in the other side of light incident. In concave lens, you have focal point in the same side of light incident. So here the description of three things when you are dealing with the lenses. Focal point, the point at which rays meet after refraction. That means after going through the lens, or the point from which diverging rays appears to proceed. So you can see light is coming from this point, We call that point as focal point. Then focal length. It is the distance between the lens axis. What is lens axis? This one, lens axis. Right? Lens axis. So distance between lens axis and the focal point we call as focal length. And then the optical axis goes through the center of lens. Actually, the optical axis also same as lens axis. Right? So these three parameters are very important when you are working with lenses. Then, as we discussed, how images are created from the mirror, how the image formed by a lens. So here you can see converging lens, right? Like this. So all the time when you need to decide about the image formed by a lens, you need at least three rays coming from the object. And we are using these two, it's, you can say like a loan, or it's kind of the way these specific rays are behave. What are those? One is ray comes in parallel to the optical axis. Ray come to parallel to the optical axis. Optical axis, this one. One mistake here, right? Focal length and the optical axis here. Lens axis, yes, this one. Optical axis, actually this one. Goes through the center of the lens. This one. Right? So, yes. So, rays come parallel to the optical axis, refracts through the focal point. So, if it is parallel, it goes through F, focal point. And rays come to the center of the lens, goes straight through it. So, if the light ray comes like this, it will go straight through the lens. And if you mark same focal distance in the other side of the lens, and if the coming or the incident ray is passing through this focal point, it will goes after the refraction, it will go parallel. So using these 2-3 rays, you can take the idea about image. So you can see this image, if you compare the height of the image, it is less and it is converted. This dot is here now, this one is here, right? And what about this one? So you can see when the light incident to concave lens, it's like spread out. So, but again, you can use these 2 rays, which is specific rays. The ray come parallel to the optical axis, that means this one. So, it should goes through the focal point. Now, since this is concave lens, it is spread out. So, spreading out like it comes through the F, like this. Then the ray comes to the central, goes straight. So what are the crossing point of these 2 rays is this. So image is somewhere here. So now this image is size-wise smaller than the previous one, but it is not converted, right? So actually, depending on where you put the object, image also different. So if you want, if you can try out by drawing few ray diagrams. So we are not doing that part deeply here, but you should know these 2 specific rays, which is comes in parallel, goes through the focal point, and which comes through the center, going straight through it. And you can decide the image properties, basic image properties using these two rays. And there's a mathematical way to do this ray diagram part like this. That is using this lens equation. We call this one as lens equation. F for the focal length, P for the object distance. So which means here it is this one, object distance, and I for the image distance, like this. Right. And when you are dealing with lenses, again, magnification is a property that lens have. Again, you can calculate it using this equation, image distance divided by the object distance, V over U. Right, so this gives how much larger or the small is the resultant image. Right, and we are defining power of lens as well. So power of lens is just 1 over focal length. So if you have convex lens, we take it as positive, and if it is concave lens, we take it as negative. Right? Right. So that's regarding actually the geometrical part. We can say this mostly the reflection and refraction. These are the two phenomena that I wanted to discuss with you. And then mirrors and lenses, which the two phenomenon reflection and refraction involves. So is it clear up to that point? Any questions? Any questions?
No, madam.
Right. Okay. So then actually we will discuss very briefly, just to give you an introduction regarding optical instruments. So under that, we will discuss 3 objects. Actually, the first one is the eye. Right? The optical instrument that all of us has is the eye. Then man-made ones, telescopes and microscope. Telescope, actually we used to see objects that are far away. Most of the time, the planets, stars, like that far away things. Then microscope, actually to see very small objects, right? So if you take the eye, this is how you can see, right? So let's say if you have tree, so you have lens in your eye, so it will focus it to your retina. Actually, we will receive this inverted image in our eye, and the brain has the ability to read it in the correct way, right? And we know lot of us use spectacles to correct our vision. So what are the two problems that can arise with the vision? Some people can't see the images or the objects actually which are far away. Some people can't see the things in very close. What is the reason? For both case, problem is image is not create for the focus at retina. So now here you can see light ray from object. So it will focus behind the retina. So the people can't see the things clearly. How we correct this? Now we want to converge it before this point. So we will use therefore convex lens. Then it will focus exactly on retina. Right? So again it depends on power of the lens. So that is why those properties, power, magnification, those things you need. Right? So this is for the people who can't see the object which is close to the eye, because it makes the image somewhere behind the retina. So using convex lens you can correct. Then here also same problem, we have light rays from far object and it will focus before the light ray reach to retina. Again, person can't see the things clearly. So what we want here, we need to spread out it more. So therefore we will use concave lens. So then this light will spread out little bit and then focus exactly on retina. So the person can read or can take the correct image. Right? So actually these things are very familiar things, day-to-day things. What you need to learn is the logic or the science behind this. That is the importance of this course. Right? Right. Then for the telescopes and microscopes, I'm not going that much detail. So I will share very good YouTube videos regarding telescope and microscope. You can refer that. So then, yes. So when it comes to the telescope again and the microscope as well, these properties in the lenses like magnification, power. So these things you need to decide according to the requirement. Right. So anything need to discuss? So we have come the end of the session. And end of the course as well. So I'll try to share your continuous assessment marks. And I will schedule the makeup quiz as well. Like somewhere in next week at night, 10 p.m. or something, then you can take it. Any questions?
Excuse me madam. එතකොට මේ
Yes.
end exam එකට මේ දක්වා කරපු හැම එකකින්ම එනවද madam ප්‍රශ්න?
Oh. Oh. මුළු syllabus එකෙන්ම.
හරි madam, thank you.
Right. There's LMS, regarding LMS grade. I didn't publish any grades yet, but I think once you do a LMS quiz, you can go there and check your marks and the grade. Then if you can see something like that, it is the grade, I think. I didn't publish anything. Write 0192. Regarding the LMS grade, මම finalized grades publish කරේ නෑ. ඔයාලට පේනවා නම් ඒ පේන LMS එකේ කරාම ගිහිල්ලා බලන්න පුළුවන් ඔයගොල්ලන්ට. ඒකයි. හරි. Any other questions? Seems no questions. Okay, then I'll stop the session and wish you good luck for the exam as well. Please check LMS time to time if there are any message or anything. I will put it in LMS. Right? Okay, right. Thank you for joining.
Thank you madam.